Okay, so in continuation of successive differentiation, so today we to find the nth derivative, nth derivative of logarithmic function. Logarithmic function means log ax plus b. So here we calculate or we obtain the nth derivative of log ax plus b. So we write down as y is equal to log ax plus b. So y is equal to log ax plus b. So this is our equation number 1. So we differentiate equation 1 with respect to x. So we write down as y1. So y1 is equal to the differentiation of log x. So the differentiation of log x is 1 upon x. So that means we write down as 1 upon ax plus b. And the differentiation of ax plus b, that is a. So this is our equation number 2. Now we can write this equation as in this way. So that means a into ax plus b raised to the power minus 1. So previously we have studied about the nth derivative of 1 upon ax plus b. So similar way we see that means one way we have first derivative, that means y1. So that means the coefficient a having power 1 and the power is ax plus b is also 1. So now differentiate again with respect to x. So we write down as y2. Y2 is equal to a into minus 1, the coefficient we write down as the power. So, and this can be written as ax plus b raised to the power minus 2, and the differentiation of ax plus b is a. So this we can write down as, so a into a is equal to a square. Here is minus 1, and we write down the ax plus b raised to the power minus 2. Sorry. So ax plus b raised to the power minus 2. So this can be written as ax. So here is the minus 2. So now again we differentiate. So again differentiate. So we write down as y3. Y3 is equal to a square into minus 1, and the differentiation when we do the differentiation of ax plus b raised to the power minus 2 is, so we write down as minus 3, and the differentiation of ax plus b is a. So this can be written as y3 is equal to, we write down this as minus 1 minus 2 and ax plus b raised to the power minus 3 into a cube. So this is our third derivative. Okay, so we can give the equation number 3. And when we write down the fourth derivative, so we write down the similarly y4. So y4 fourth derivative directly we can write down as the above. So minus 1 minus 2 minus 3 into ax plus b raised to the power minus 4 into a raised to the power 4. So when we write the fourth derivative, similarly we do the nth derivative. So the nth derivative, so we write down as yn. Yn is equal to minus 1, minus 2, minus 3. Okay, so this will be written as minus n minus 1. And this term will be ax plus b raised to the power n and a raised to the power n. Okay, so this can be written as yn. So how many negative signs is n minus 1? So we write down as minus 1 raised to the power n minus 1 into 1 into 2 into 3 up to n minus 1. And this can be written as this is minus n. So ax plus b raised to the power minus n and a raised to the power n. So this can be written as yn is equal to minus 1 raised to the power n minus 1 and 1 to n minus 1. So this is factorial n minus 1. So this is n minus 1 factorial into a raised to the power n upon, this can be written as ax plus b raised to the power n. So this is the nth derivative. nth derivative of what? So nth derivative of log ax plus b. Nth derivative of log ax plus b is equal to minus 1 raised to the power n minus 1 factorial a raised to the power n upon ax plus b raised to the power n. So then we can take the example. So how to apply this one? So when we have function, so we write down if function y is equal to log 5x plus 6. So we have the function log 5x plus 6, then find yn. So we have to find the yn. So we use the formula, have a formula directly. So we calculate the yn. So that means the nth derivative of log 5x plus 6. So this is equal to minus 1 raised to the power n minus 1, n minus 1 to the factorial, and a, here a is equal to 5 raised to the power n upon 5x plus 6 raised to the power n. Now when you calculate the particular, so that means when we put the value of n, so as per the value of n, that means when we find out the fifth derivative, sixth derivative, 10th derivative, so when we put the value of n is 6/10. Okay, so thank you.